So dear students, in the last lecture we have finished Fourier series of the function. Okay, in that we have seen how to find half range sine and cosine Fourier series. Now today we are going to start next module, that is a function of complex variable, which is the very important module for you. The name of module is what? Function of complex variable. Function of complex variable. Function of complex variables. Okay, so what is the function of complex variable? You know the function, the function in real case. Let us recall the function. Let us recall the function. Recall that recall that f is a rule. F is a rule that assigns to each element to each element each element in a set A, each element to the set A, and A and one and only one element, one and only one element, one and only one element in a set B, in a set B. Okay, now if f assigns the value v, if f assigns the value b, small b, if f assigns the value b to the element a in A, to the element small a in A, then then we write this function as what? B equal to f of A. Okay, means what? Suppose we have the real axis and this is the imaginary axis. Okay, this is x and this is your y. Okay, if suppose point A is here. Okay, point A is here, so this for each element of A there correspond a function, for function f of A. Okay, so for this is here f of A. Okay, for this case we'll have f of A. Okay, for each A you will find a unique function. Okay, suppose here another point, suppose B is this is A1, suppose A1, and here A2 is there. So for this A2, you will have the another, you will have another function, that is what? F of A2. Okay, so for each element in A there correspond one and only one element in the set B, such that f of A can be written as B. Okay, so in this way you can define a function f of x in real case. Okay, I hope you understood what is your
So
function.
आवाज समझा एक मिनट.
देखिए, what is your function? Your function is what? Your function f is from A to B. F is from A to B. This is known as what? This is a function. Suppose A is the element in capital A. So for this element, there correspond a unique element in B. There correspond unique element unique element in B such that if I apply F in this element, so you will get such that F of A can be written as what? B. F of A can be written as what? B. Getting? Uh,
Yeah, sir.
for each element of A in A, there correspond a unique element in B such that F of A can be written as what? F of B. So this is the function in real case. Okay. This is the definition of function in real case. Similarly, you can define what function in what? In complex case. So suppose this is your plane. This is your plane. This is your x-axis, and this is y-axis. Okay. And suppose we define this function. This is your domain of the function. Okay. So this is domain of function. Write down domain. Here this is A is known as what? Domain. B is known as what? Codomain. A is what? A is called domain. A is known as domain, and B is what? Codomain. Okay. This is your domain, and this is your what? Codomain. Okay. So this is domain of the function. Okay. And now we will have codomain of the function. Here we define here codomain of the function in complex plane. Okay. And this plane, this is what known as Z plane. Z plane means what? XY plane. X and Y. This is XY plane. Here you have origin. Okay. But this is the imaginary plane, and this imaginary plane is known as what? Omega plane. Omega plane. This is omega plane, and this is known as what? Codomain. Codomain. Okay. And if you define this function from domain to codomain, so uh, this function is what? Written as what? F of z. But f of z is equal to what? F of z is equal to omega. So this function defined as what? Omega equal to f of z from the function from the domain, this domain to codomain. This domain belong to the what? Domain is from z plane. Z plane is known as what? XY plane, and this is the omega plane. Actually, this omega plane, we just imagine or visualize how the plane look like. So but omega is what? Your omega is u plus iv. U plus iv. U is the what? Function of xy, and v is also known as function of xy. So this is your origin, and this is u, and this is what? V. Okay. So now we can define the function in complex variable. Okay. So by a rule or set of rule, we can find one and only, we can find one or more complex number omega for every complex number z in the given domain. Then we can say that omega is what? Function of z, and it is written as omega equal to f of z, or this equal to u plus iv, where u and v are functions of x and y. Okay. Why this called a function of complex variable? Because here z and omega both are complex quantity. That's why it is known as what? Functions of complex variable. Getting? Yes or no?
Sir.
See, let us see the definition. If by a rule, or you can say that a set of rules, we can find find one or one or more complex number, one or more complex numbers, say this is what omega. So for every every z, but z is what, you know that z is x plus iy. For every z in a given domain, in a given domain z, this is z planar, your z belong to the this domain. Okay, so for every z in the given domain, we say that we say that we say that omega equal to f of z, omega equal to f of z, or you can say this is what u plus iv, where f of z is what function of x and y, where f of z is a function of is a function of z. Okay, first one is what single valued function, single valued function. Okay, if for a given z, for a given complex number z, complex number, for a given complex number z, there corresponds there corresponds there corresponds one and only one omega, then we can say that then then we can say that omega is what, then we can say that omega equal to f of z is a single valued function, single valued function. Okay, and what are the example behind this? What are the example? What are the example? Suppose we have f of z. Okay, f of z equal to z square. Okay, f of z equal to what, z square. If I put here, if I put here uh, if I put here z equal to what, I. Okay, I is the complex number, then we get f of I equal to what, I square, but I square is what, minus 1. I square is minus 1. For a given z, we have only one function value. Okay, means for a given z, there correspond one and only one omega, then we can say that what, omega is a single valued function. So for given z equal to I, we will have only one omega, that is what, minus 1. So this function is what, f of z equal to z square is what, a single valued function. Why is this so? Because it give only single valued. Getting, it gives only single value. You understood what is the single value function? You got it? What is the single value function?
हाँ सर.
Yes, sir.
Okay, Abhishek, you got?
Yes, sir. Yes, sir.
Okay, now we define multiple value function. Multiple value function. Multiple valued function. Okay, multiple value function. And what is the multiple value function? Similar way, in similar way, we can define if for given complex number z, if for a given complex number z, complex number z, okay, there there corresponds there corresponds two or more values of values of omega, then the function is called then the function is called multiple valued function. Multiple valued function. Okay. Then the function is known as what? Multiple value function. Means what? For given complex number z, for given complex number z, if there corresponds two or more value of the function omega, then that function is known as what? Multiple valued function. Okay. Now let us see the example so that you can understand the definition of multiple value function. Okay. Suppose we have the function f of z, f of z, but f of z is what? Omega. So we have the function omega equal to f of z, and that is what? So omega equal to f of z, omega equal to f of z, and this equal to z raised to 1 by n. 1 by n is a multiple valued function. Multiple valued function. Why is this so? Because this function gives nth root. Nth root. So this is what? Multiple valued function. Getting? Yes or no, students? You got it? You got it? What is the single value function and what is the multiple value function?
Yes, sir.
हाँ, डिफिनेशन पे ज़्यादा जाना नहीं है आपको, जस्ट मैं आपको बस एलोबरेट कर रहा हूँ कि इसका जो टर्म्स आएंगे उसके क्या मीनिंग होते हैं. ठीक है. नाउ हियर इफ आई राइट नोट we know that omega is what? Omega is a function of z. Okay, but omega is a function of z, but f of z is what? F of z is function of xy. This is u x comma y plus I v of x comma y. Okay, so omega can also be written as u of xy plus I times of v of xy, where u and v both are functions of x and y. Okay, so where u and v both are functions of x and y. Okay, and we write omega equal to u of xy plus I times of v of xy. Okay, so just remember this. Now what? Now let us move to the next topic, that is what? Limit of a function. So here we will see limit and continuity of the function. What is the limit of the function defined in the domain, and what is the continuity of the function defined in the given domain? Okay, so just define limit of a function. Limit limit of a function. Let us define the limit. Let omega equal to f of z be a single valued function. Single valued function. Omega equal to f of z be a single valued function of z defined on defined on closed and defined on closed and bounded domain define and closed and bounded domain, say domain name is D. Okay, and for a given epsilon, for a given epsilon is greater than 0, there exist there see here epsilon may be very small, but which is what, greater than 0. So for a given epsilon greater than 0, there exist there exist there exist delta which is greater than 0. There exists delta greater than 0 such that modulus of f of z minus f of z naught is less than epsilon for all z for all z for which 0 is less than modulus of z minus z naught and which is less than delta. Okay, then then we say that we say that then we say that f of z naught equal to what, omega naught is the limit of is the limit of function f of z as z tending toward z naught. Okay, and we write limit z tending to z naught f of z equal to what, omega naught. Okay, so this is the definition of a limit of a function. And what is the actual definition? If you have the function f of z which is a single valued, and that function must be defined in the closed and bounded region, you can say D, your region is D, then for a given positive epsilon there exists a delta, however small, such that modulus of f of z minus f of z naught is less than epsilon for all z. So this condition true for all z, for which this condition must hold. That is what, 0 is less than modulus of z minus z naught, which is less than delta. Then we can say that omega naught is what, limit of that function as z tending to z naught, and this condition can be written as what, limit z tending to z naught f of z equal to omega. Okay, so this is a definition of limit of function. Now here we will write note. Here we will write note. Okay, note the limit of f of z as z tending to z naught exists if and only if limit of limits of real and imaginary imaginary parts both exist both exist means what means what limit z tending to z naught f of z, okay, and this limit exists, this limit what exists if and only if limit x comma y tending to what x naught comma y naught u of x comma y and limit x comma y tending to what tending to x naught y naught v of x comma y exist, okay, means if this limit exists if and only if this limit exists means if real limit of real part and imaginary part both are exist, then we can say that function limit exists, otherwise not. Getting what the definition of limit?
Yes, sir.
Means what your f is what consists of two function u and v, okay, if I apply limit as z tending to z naught then limit of function f of z as z tending to z naught exists if and only if limit of u as z tending to z naught exists as well as limit of v as z tending to z naught exist. Getting? So you can write this is what if and only if limit z tending to z naught u z tending to z naught u of x y and limit z tending to what z tending to x y and this is what this is limit z tending to z naught u of z and v of z exist, okay. So this is the important note, you must remember this, okay. Now let us do some problem based on this, then you will understand, okay, what is the limit of the function defined in the given domain, okay. Now see here, the limit of the function does not depend upon the path, okay. Limit, also note that, note number 2, this is your note number 1. Limit of function does not depend on chosen path, okay. If limit of the function depends on the path, then limit does not exist. If so, means what? If limit depends on the path, if so, then limit of function does not exist, means what? If limit of function depends on the path, then limit of that function does not exist, okay. So this is the note, you must remember this note, this is the important key note, just Remember this. Let us do some problem, then you will understand what are the limit of the function. Yes, example. Find the limit of the function. Find the limit of the function. Find the limit of the function f of z equal to what? Zq minus 1 divide by z minus 1 as z tending to 1. Okay, as z tending to 1. You have to find the limit of this function. Let us see the solution for this. Solution. Okay, given function f of z is what? Zq minus 1 divided by what? Z minus 1. Okay, this function is given to you. Now taking limit as z tending to 1. Taking limit as z tending to 1 on both sides. Just apply the limit. So limit z tending to 1 f of z equal to what? Limit z tending to 1 zq minus 1 divided by z minus 1. Okay, so this equal to what? This equal to, see please here, you don't apply the limit here directly. Okay, if you putting here limit, so this become what? 1 to the power q, that is 1. So 1 minus 1 0. And if you apply here z equal to 1 here, so 1 minus 1, that is 0. So this become what? 0 upon 0. So limit of the function does not exist. Okay, so don't apply the limit directly, just see here. So limit z tending to 1, and this is what? This is the formula aq minus bq. Okay, this is the formula aq minus bq. Just apply the formula for this. What is the formula for aq minus bq? Can anybody tell me? Yes,
A minus B into
a minus b
A
into what?
square plus B square plus 2AB.
हाँ, just apply करो. So this is formula a minus b, then a square plus
2ab
2ab नहीं बचा, ab and plus b
b
square.
square.
Okay, just apply this. So this is what? Z minus 1. Okay, and here z square plus ab. A is this and b is this, that is what? Z. Okay, and plus b square. 1 का square is 1. Okay, and divide by z minus 1. Okay, so this quantity and this quantity will cancel. Why this so? Just mention the region as z tending to 1, as z tending to 1 implies z minus 1 is not equal to 0. Okay, this is the reason behind that. So this equal to what? I am writing here, this equal to limit z tending to 1, and write down the remaining function, that is z square plus z and plus 1. Okay, now apply the limit inside the bracket. So let us move to the next page. So we write here, therefore limit z tending to 1 f of z, and this is equal to what? Limit z tending to 1 z square and plus z plus 1. Okay, Now apply the limit. So this is limit z tending to 1, z tending to 1, z square plus limit z tending to 1, z and plus limit z tending to 1 and constant term 1. Okay. So just replace the limit here, z square and plus here 1 and plus 1. Okay. So this gives what? 3. This gives 3 as a limit of given function. Okay. Therefore you can write, therefore the limit z tending to 1, zq minus 1 divide by what? Z minus 1 equal to 3. Here 3 is the limit of this function. I hope you understood this problem. Yes, yes or no, student? Is this easy or difficult? Below?
Yes, sir.
Easy, sir.
Yes, yes. This is the easy beginning problem. है easy है. Example number 2. Example number 2. Find the limit of the function. Find the limit as z tending to what? I zq plus 2 times of z square and plus 6 and divide by what? Z minus I. Divide by z minus I. Let us see how to find the limit of this function. Okay, solution. What have to find out? We have to find out limit of this. Just write down limit z tending to I zq plus 2z square plus 6 and divide by what? Z minus 1. Okay, this equal to, I am writing here limit z tending to I. Okay, now can you apply the limit here directly? If I see here, if I applying the limit here directly, so on the numerator there is no problem, but on the denominator here this is I. On the denominator here we will have z minus I. Okay, so this become what? I minus I, that is 0. On the denominator there is 0, which is what? Which is dangerous to us. Okay, why is this so? Because limit of the function does not exist. Okay, so for this what I have to do, we just multiply and divide by its complex conjugate. Okay, so we have zq and plus 2z square and plus 6 and divide by what? Z minus I. Here we write here z plus I and z plus I. Z plus I and z plus I. Getting? So this is multiplication. Huh? This is your multiplication. So just write down here. So we'll have limit z tending to I. We have zq plus 2z square plus 6, okay, into z plus I. Okay, and divide by, if you multiply here I, so this is what? Z square minus I square. Okay, why this so? Since we know that a square minus b square is what? A minus b and a plus b. Yes or no? Yes or no, student?
Yes,
Tell me.
sir. Yes,
Ye-
sir.
Yeah. But I square is what? I square is minus 1. So limit z tending to I zq plus 2 times of z square and plus 6 we write here as it is, and z plus I, and divide by what?
Z square minus 1.
Z square minus I square is minus 1, so this is plus.
Oh, हाँ,
So this,
Z square plus 1.
yes, so this will what? This is z square plus 1. Okay, see here, now just apply the limit directly over here. Just apply the limit directly. So this is what? I'm not going to multiply then apply the limit separately like this. Okay, so if you apply the limit here directly, just apply. So this is I q plus 2 times of I square plus 6. Okay, and here I plus I, and this is divided by I square plus 1, but I square is minus 1, so limit of this function does not exist again. Okay, so but I square is there na. See here, denominator just as a denominator.
सर यहाँ पे वापस हो ये कर जाएगा ना सर, अगर पहले कर सकते तो
नहीं नहीं,
पहले भी नहीं होगा।
पहले नहीं करना है आपको,
हाँ, तो
पहले
इसको वापस मतलब ये आई स्क्वायर लेके वापस सॉल्व करो।
यस यस, यहाँ पे देखिए इसको if I simplify, this is I square is what? Minus 1, but this is what? So this become what? Minus I. Okay, and this is minus 2, but I square is minus 1, and plus 6, and divide by what? Minus 1 plus 1, and this is what? 2 times of I. So this gives what? This gives what? If I multiply here, just multiply. So this is minus 2 times of I square minus 2I, 2 to the 4I. So this is what? This is 4I. Yes. So this is your 4I. Just multiply inside. 4I and plus 6 to the 12I, and divide by what? Divide by 0. So this gives what? Infinity. This gives infinity. So we can say the limit of this function does not exist. Okay. Therefore, let us move to the next page. Therefore, limit z tending to I, and what is our function? Zq plus 2z square plus 6, zq plus 2z square plus 6, and divide by what? Z minus I. Divided by z minus I does not exist. Okay, limit of this function does not exist. I hope you understood this. Should I give some example based on this?
Okay, sir.
Example दे दूं कुछ? Examples. Find the limit of the following. Find the limit of the following. Of the following. Okay, number one, you'll take limit as just take limit of the function, limit z tending to I, z square plus 1 divided by z raised to 6 plus 1, and second one is the limit z tending to minus 3I, z square minus 2z and plus 3, and divide by z z minus 3I. Okay, these are two problem exercise for you, so please do this problem at your home.